We read some of the comments about the sound yesterday, so I will do my best to keep the microphone in front of my mouth, in front of your mouth. Today I'll save our voices too and help us hear what's going on around us. So I have one math joke. It's my best math joke. It's probably my only math joke, and I forgot to tell it the first day. So now, just like the kids, you can't yell out. Actually, there's more than one answer, evidently, that's funny to this joke and it's appropriate. So teachers come up with other answers, so you may have a different answer. So it's a kind of a riddle. Why wouldn't the mathematician eat his carrots? So don't yell out, but just think about it. You can whisper to somebody if you think you know why. Why wouldn't the mathematician eat his carrots? Anybody have any thoughts?
Because he wanted pie?
That was one that a teacher had come up with. Say that.
Because he wanted pie?
He wanted to save room for pie, or he wanted pie. So that's one a teacher came up with. That wasn't the one I had heard. Anybody have any other guesses? 6th grade teachers.
Or the pun. He didn't know his veggie tables.
He didn't know his veggie tables. Oh, very cute. Didn't know his veggie tables. Anybody else? What kind of vegetable is a carrot? Because it wasn't a square root. So that's as good as they get for me on math jokes. But I also didn't share something that I think really is at the heart of what we're doing here. When I got to support teachers at my site, I think I told you I was teaching 3rd grade one week and then out in classrooms with teachers that wanted to look at teaching in a way that's responsive to children. And we had a brand new teacher, and 2nd grade, and she and I would plan together a lesson around what she was curious about learning about her children, and based on what she had already learned about her children. And then she would pose the problem to her kids, and we'd walk around and kind of like, you know, Mr. Garcia problem, see what they did, talk to them a little bit, and then choose a couple kids to share. And so we had written a problem for her class, and we had anticipated the strategies ahead of time and thought about the questions we might ask. And I was getting ready to go in her classroom. And before I came in, the kids, she said, Miss Case is coming in, and the kids said, oh, we're going to do CGI, which I don't know if you can do CGI, you just do math, right? But somehow CGI got into their thinking. And so they asked her, Mrs. Caratonuti, what's CGI mean? Well, we forgot to tell her. You know, she was new. We didn't have the book yet for her. We were just trying, getting her curious about kids thinking. So she really didn't know. So she put CGI up on the board and asked kids, well, what it really means, does anybody know what it really means, is cognitively guided instruction, which is a mouthful, right? But the kids didn't know that. She didn't know that. She said, what do you think it might mean? And so I think what they came up with was, to me, the heart of CGI. They said it must mean children's good ideas. So if you don't really do CGI, kids solve math in ways that make sense to them, and then we try and understand how they're thinking, because what we find out is kids think differently about math than we do. And so in order to teach kids mathematics in a way that's responsive to their thinking, we have to kind of learn how kids think, and that's kind of what we've been doing here together. And then how do we respond to kids thinking in ways that are build on what they know, this idea of building on prior knowledge. So children's good ideas is really what we're all about. So last night, you had a little bit of reading assignment to look at the introduction and chapter 1. And so what I'd like you to do is 2 things. First, just look through and pull out something that was, for whatever reason, was interesting to you. It might be something that clarified things more for you. Maybe something that gave you another question. Maybe it's something you're not sure you agree with yet, or something you want to know more about. So whatever it is that just stood out for you, take note of that. And then I'm going to ask you first to share in your small groups. And then each small group, choose one of the things that were shared, and we'll just go around all tables and share one thing from each table. So take a minute to look through, talk at your tables, and then we'll share one thing from each table.
Got it? What? And I don't know why that's part of it.
That's how we all got it. It all got contributed today.
So in measurement, you don't know. You don't know how many people. At least I should figure well, it's good. Never Quotient is the answer, which is from multiplication. That's very different.
You switch it from multiplication to division. You should get the quotient. You multiply the
Product
the dividend and multiply the quotient times the divisor. You get the dividend.
Right.
Am I right?
What's that? The number of groups that would take when I do the division product, it's 15 divided by 3, right? 3 circles, and you put 6 in the circle, so you get the quotient. So that would mean 3 divided
Sure. Yeah, okay. I got it. Yeah, 15.
It probably doesn't ever matter, but I've never heard the word partition.
I've heard it called partition, pre-service training.
Oh, really?
Partition. Oh, I remember that. I do remember that Willie Mays batted 312 in 1972. For some strange reason. Stuff that's on steroids.
And I don't. Well, it's all about
How did this children draw on their stage of fraction numbers rather
That might have been
but I might express it.
she discovered practice, and that's what that which made it a powerful thing. Yeah, it was in the introduction. It was in the introduction.
So one more minute, make sure you've chosen one of the things that was brought up at your tables to share with the whole group.
Take that result and say, okay, this is what I wanted to show.
Well, it's probably the epitome of differentiating working on often students on advanced. Apple.
More powerful.
That's where in any type of exam. It's true.
Okay, so let's share some of the things that stood out at your table from either the introduction or chapter 1. You guys?
I think a couple of things. One was, it talks about having the students work on problems with things they're familiar with, like food. I mean, they're all used to, sharing their food and dividing things up, so that makes it real for them. And then also, the part where it says posing problems to children without first presenting a strategy for solving the problems is an important thing to remember because we're used to doing it the other way. So that stood out.
Yeah, it kind of flips it. They're gonna solve the problem and through that skill.
In the introduction, I found 2 parts. On page XXI, it talks about that instruction should start with word problems and then go to equations. And I think we always do it, well, not we, I mean, maybe I do it backwards. No, do the equations first and then do the word problems because that's so hard for them and they freeze up. But I thought that was really interesting. The other thing is on the last page of the introduction, it's eye-opening. Teachers learning to listen to children in a more responsive manner. That's what it's essential to effective teaching. And I think we do listen to children, but I felt as though maybe we're going to get a different sense of listening. That it's going to, the next 3 years, we're going to be listening differently, which will be nice.
So that was my big change. I was used to listening to kids tell me what the next step was. So it was like, okay, what do I do first? You cross out the 0, or you cross out the 9, and then what? Put the 8 above. So when I now was just having to listen to kids say things like, Roger, no, Mrs. Case, 2/3 is more than a half. It's a half of a third more than a half. It was a 6. It wasn't anything I had ever thought about. So to listen in a new way. I was given some really good advice that I'll pass on to you that helped me grow in my listening to kids, is when I first started listening to kids, and it was in a 2nd, 3rd grade class, and they were doing things that I had never thought about. I would walk by and I would look at, what was the little guy, Albert. And I'd see what he would do, and I'd say, Albert, my only question then that I had was, tell me what you did. So he would. And then I would go, oh. I wouldn't do that in the air, but I had no idea. So, and where did my eyes fall before I even started listening to him at the answer? That still happens to me sometimes, but it's for a different reason. So it helps me listen to how they got that answer, not, oh, did they get the answer? Now good, I'll take time to listen. So it's for a different reason now. But one of the researchers that I went to hear said to me, or to the group, when a child's explaining his or her strategy, don't walk away until you understand what he or she did. And that helped me really grow. So I would have stayed longer with Albert. And I began to stay longer with the kids and say, wait, I don't know where that came from. What do you mean when you said you did this? And sometimes it would take a long time, but it helped me then go through the same thinking that they did. And what was so neat is either that problem or down the road a problem or the next year, guess what? Kids think in these predictable ways. I was going to see it again. It might not look exactly like it, but then I would hear another kid another year start going like that, and I'm like, wait. Oh, yeah, like that. I mean, my mind would come back. I'm like, Roger, okay, I'm with you. And it's kind of a fun ride because you're like, okay, I'm with you. And then you think they're going to go this way, and they go, and so you're like, wait, come back. So it's kind of a fascinating way to listen to kids. We're listening to that formative assessment, what we hear all the time, formative assessment. Well, formative assessment means you're gonna listen to kids in a way that is gonna build off their thinking. And so hopefully the work that we're doing in here, as you listen to kids, the frameworks of these strategy levels and what's important to listen for will give us some structure. In knowing kind of what are the big things I'm supposed to be listening for and where are they in this kind of development.
Okay. Well, I know, but it's kind of the same points that have already been brought up about starting from that developmental process and going with the children. We're also talking about how when we start doing this kind of thing in our classrooms, these kids, and especially in our 4th, 5th, and 6th, they've been in 3 years of very regimented math, and that when we start doing this, how we're going to have to probably do some guided modeling with them for them to start to feel comfortable with this free thought thinking, and them to be able to go and be comfortable with going and having different answers and different ways to look at things. So it's kind of...
Could be really new to kids. One thing to keep in the back of your mind is what you might, if you want kids to be successful on their own with a story problem, and maybe they haven't had a whole lot of opportunity to solve problems on their own, what kind of problem are you going to give them? Yeah. So it may be at the early point of instruction, it's not so much about using the numbers or that are at my grade level, but maybe it's about just building confidence that I am a problem solver. I can make sense of things on my own.
I'm just kind of piggybacking on you and just developmentally how they like to have things. I'm at 6, but I would probably start at something real simple and give them that success and have them start, with a 3 and a 2 or something where they'll get some kind of fractional part, but it will be having. They can have this and then have this and have it.
So now you're getting to see how thinking about how kids think, I can begin to see what would be an early problem. And what would be more middle of the year I could expect them to solve, and what could be more at the end.
I think that kids will attack pretty complex problems if they are invested in the process. So sometimes I think it's just our job to find the right scenarios, the right story to pull them in. And Elizabeth and I were talking because I got my Fitbit toward the end of last year, and the kids and I started talking about it, how many steps my goal was. And then it naturally lended itself to percentages and fractions, and the kids were into it. When I get to school, they'd be like, how many steps are you on? They knew how many steps were around the track one. And we were just developed this conversation, this natural conversation that we were always talking about math. And it was exciting. I wish it wasn't like the last 2 weeks of school, but I did some great things last week.
I watched a first grade teacher pose the problem to her kids. If we were to see the equation, it would have been 4 times 10 minus 11. And this is first grade. But she put it in exactly what you said. She had a dog named Thatcher, and he was a rascal. He was a terrier, and if you know terriers, they can be rascals. And so she did this whole story. And she said, today's this story about Thatcher. And they're like, oh, they want to hear, what did he do now? Oh, just wait till you hear what he did now. And they knew sometimes it was a make-believe, but they didn't care. So she went through this whole thing that she had gone to the store and she had bought 4 boxes of cookies with 10 cookies in each box. And she went through, you know, when they ring them out, oh yeah, it goes beep, and so there goes 1 box. So they were going through this whole story. And there's another, and then that box went in, so she's taking these boxes home, these 4 boxes home, and she puts them on the counter, and the phone rings. And I'm like, oh no. Did Patrick get him? What do you think? Yeah, because I know he jumps. You've told us that. He jumps. He did. And he ate some of them. How many? Oh, yeah. He ate 11 of them. I wonder if you could figure out how many cookies I still had left. First grade, boom. They were drawing pictures, count by tens, figuring out what to do. And it was exactly because of what you said. They were so excited. They could visualize the story. They weren't trying to solve 4 times 10 plus 11. They were trying to solve a story about a bunch of cookies. And in that, they were learning about groups of 10, and that 11 is made up of a group of 10, and we can count 10 as 1. And so, yeah, putting their names in it or things that they're interested in.
The thing that jumped out to us was the concept of building meaning before introducing the symbol. Oh, because it makes sense. And you know, when you look at the problem on page 21, we've seen that so often. You know, we're trying to construct meaning from symbols.
So it's the free outline.
It's backwards. Yeah.
So some of this stuff may kind of resonate with you, like this makes so much more sense than what traditionally has happened.
The thing that we found interesting on page kind of 4 and 5, where it talked about how a 5th grader, Holly, was asked to put the cupcakes. The problem was half a cupcake frosting on each cupcake, excuse me. And the teacher asked her how much it was, and she said it was 4 halves. Or excuse me, yeah, 4 halves. And then she couldn't tell her how much it was altogether. It's 4 cupcakes. And then the same problem with Ernesto, they divided the cookie in half and then asked him to show where half of the whole cookie was. And then he divided it into 4. And so it's just interesting that they have no foundation and they already have, okay, well, 4, so I already know I have to draw 2 lines. Instead of saying, okay, the whole cookie, we have to just draw 1 line and that will be 1/4 of it. So how do you change that kind of mindset, you know, of them? How do you help strengthen that?
I think she was just talking about what I was going to talk about, Ernesto. But I taught 3rd grade before going to 6th and 4th, and we used to spend a lot of time just giving kids circle cutouts and having them fold them. Am I supposed to stand up? Oh,
You can stand up too.
you know, we would have them fold and cut them and make Christmas ornaments out of these little circle things. And what struck me is I've just become this algorithm guy. Hey, this is how you solve the problem. Just do it without any experience. So kind of stuff like that. So that's kind of what struck me is like we need to do more real world things where it's not an algorithm and not numbers.
The thing we talked about and that I looked at was children have to solve problems that involve objects that they can relate to. And it makes it a tangible thing for them. So one of the things that, as I was reading that, I started thinking, what if I started introducing fractions at the very beginning of the year by doing, you know, Fridays when I'm not teaching a math lesson, pulling some of these equal sharing problems and having them work at it and then journal and discuss it afterwards. So that I'm introducing fractions at the beginning of the year and the concepts. So by the time I get to fractions, it's going to be already embedded. So we've talked about that.
You can teach equal share throughout the year, not just when you're doing your fraction unit. when you talked about journals, just another thing to share that teachers were thinking about. One district in Southern California, they want kids to write in the mathematics class. And is that kind of something you guys like to do too? So what the teachers were doing is they were having the kids solve the problems any way they wanted and then write about how they solved it. And they were finding out that the kids were being less excited about solving the story. Why do you think? So they liked solving it at the beginning, but they didn't want to write down exactly how they solved it. So we brainstormed at a coaching session. Well, if you want kids to write in mathematics, does it have to be that they're writing down the exact strategy that they just solved using a picture, numbers, or an equation? So they started thinking about other reasons. So they had the kids solve it in 2 ways and then write about something that was similar or different. Or what did you learn when you did the second way from when you did the first way? Or they would have kids find somebody who did it a different way and write how yours was similar or different. So they were doing more compare and contrast, analyzing strategies rather than just trying to write in words what I just did with an equation or what I just did in a picture or a graph. So journaling can be for a lot of different reasons. I can write. Which strategy they started playing around with numbers. What numbers would work well with this strategy? What numbers would work well with this strategy? Can you see, so they were just having kids write in different ways rather than just write down how you solved it.
It's no fair being last. Everything was covered. basically, the chapter, everybody hits, it's basically what we've been going over these 2 days and the different levels of understanding and just kind of reiterated everything that we have been talking about.
Yeah, I hope that was a big part of the reading, that it kind of cemented rather than reading it before, right? You experienced it first and then hopefully it kind of cemented some of the things we've been talking about. So this morning, just a little bit about what I'm hoping to do today, and we'll just see how our time goes, is I want to give you a chance to put some of the things that we've been learning a little bit in isolation more together, and around these equal sharing problems. So we're going to look at the classification of the problems and then that new kind of questioning framework that we looked at yesterday. And so you're going to get an opportunity to continue to analyze kids' work and with the frameworks, and then begin to practice some of the questioning. The question this morning was, how do I stop myself from rescuing kids and jumping in too soon? And one of the ways, the kids will, when you see kids solve these problems and you see the power that is coming out of them and the understanding, when you don't rescue them, that's very encouraging to us as teachers, right? So when we see what the difference is between when we rescue them and when we don't, it just motivates us to hold back a little longer. But one of the things is, if we're going to take that away, if I want to back off of that, what do I put in its place? So it's not this, right? So the questioning hopefully will let you interact with kids still in a way that's going to support or extend them, but not take over the thinking. So as we learn the questions that are helpful to kids, we'll get to play the teacher part and be a part of this fun learning that's happening, but in a different way that doesn't take the thinking away, but capitalizes on it and extends it and supports it. So, and then I want to look at this idea of, so what comes next? So my kids are beginning to, I'm using equal sharing problems, are beginning to understand what a unit fraction is, beginning to name them and combine them and be able to understand, how big they are. What comes next? So we're going to look at 2 other problems that you can pretty quickly use in conjunction with the equal sharing problems that are going to let kids continue to expand their understanding. So we're going to look at operating on fractions, but not addition and subtraction, multiplication and division. As we talked the first day, there's less equivalence that's needed. So it's starting with multiplication and division allows us to do some really nice fraction work before a lot of equivalence is needed. And as kids' equivalence gets better, then folding in more addition and subtraction. And then I also want to look at the equal sign. I don't know if you guys have had any of its, if you've had an opportunity to look at how kids in grades 1st through 6th, and then Jeannie Barron, who's with the 2nd, 3rd grade, she's looked into middle school, how kids are thinking about the equal sign. Because the last day I want to touch a little bit on equations. Because our goal is, and it's an end goal, but thinking about how kids develop, one of our goals is that kids begin to think about fractions abstractly and can do problem solving around equations. But as you guys a couple of you guys mentioned, that's after the understanding. So I want to look at how kids, how we can support that, and what kind of thinking kids do when they no longer need a story. That the story, they may need a story, just to know what operation to use, but they can also begin to just problem solve around equations. We can put an equation up on the board and ask them to think about solving it or ask if it's true or false. But in order to kind of support that, I want to spend a little time looking at how kids think about the equal sign and give you a tool that you can go right back in your classroom and learn how they think about the equal sign, and then give them opportunities to expand or clear up some of the misconceptions that are out there with the equal sign. So we got a pretty full day, and if we don't get to all of it, we'll just slide it into tomorrow. So I want to start then just looking at the two frameworks that we've had a chance to get familiar with. So we have this guy, and if we, this is the framework for equal sharing problems, that part of the division. And equal sharing problems, when kids solve equal sharing problems, even though they're on their paper, the representation may look a little different. The mathematics is basically sorts out into three big groups. Into this non-anticipatory, emergent, anticipatory, and then I keep wanting to say fully anticipatory because I need a title for that better. And then to be able to distinguish where your child is in this continuum of understanding, these on the side are these features that are going to help us decide whether a child is in non-anticipatory, emergent, or anticipatory. And those are whether or not they're representing every share, how the partitions, are they based on the number of sharers? Do they create equal shares? Do they use fraction words or notation? Or do they combine unit fractions for a final share? And then we have in each of those categories typical strategies that we see kids using in each of those. So you're going to use this one along with, and you have a blank one, but I can't find a blank one, so I'll cover this up so you can see what. Yours is just going to look like that, kind of like that. So there are more categories, but these are kind of the two that get us started as far as how to help and how to support and extend kids' thinking. So we have these two major categories. Explore the details of the child's existing strategy. So again, staying with the child. Yeah, it's kind of the one that we have Ryan's on. I didn't give you a blank one. I will find the blank ones because I have a blank one. That's why I don't have a blank one, because I didn't give you a blank one. But I will dig. So, so in the big category of explore the details of a child's strategy, it gives us some support on what that might sound like. So pose starter questions to the child. And those are just invitations to share his or her thinking. Without an invitation to share your thinking, you might not share it, right? So what would it sound like if I invited you to share your thinking? What would I say? What were you thinking? What were you thinking? What else might it sound like? What else? How'd you do this? Tell me how you did this. Come up with a couple more. What else might it sound like? Can you tell me more about that? Walk me through your strategy. So any of those kinds of things. The other one then is to press the child for a detailed explanation of his or her problem-solving process. So that the process they went through in solving that problem, and really pressing for the details about how they went about solving it. Question the child about, probe the child's representation to highlight connections to the problem context. So that one's kind of nice because the story is going to support us there. So if we're looking at the representation they used in connection with the story, we're going to be asking things like, where is this amount in your picture? When you wrote this equation, what did it mean in the story? What was happening? What do these arrows mean? What does this 2 and this 1 and those 1/2 in this box mean? So those kinds of questions, tying it back to the story. And then question the child about quantities and their relationships. So we talked about how it can be a benchmark, kind of an idea. It can just encourage them to think about how large something is. Invite the child to think ahead before executing a problem-solving step. So you saw that a little bit in Ryan's yesterday, where before he finished cutting all of them in 8s, he was asked, do you think you might already know the answer? And he was asked that for a specific reason, because now we know that if you solve it that way, everything's going to be the same, and that way it becomes a mental model. So it gives Ryan a chance to see the power in his own strategy. He didn't take that chance because he's not ready yet. But a few prompts down the road, you try it again. Teachers often say, before you even start, or what do you think you're going to do? I'm going to cut them all in 8s. Why? Because there's 8 kids. So do you think you have an idea of what it's going to be already? No. Well, take a few minutes, right? So take a minute or so and see if you can figure it out. Let them mess around with it, see if they might be able to do those kinds of things. So it's giving them a chance when you think they're ready to kind of be able to think about some things in their head, things that make sense in their head. And then that last category, ensure that they're making sense of the story context. As we know, you're going to solve the problem that's in your head, right? So their solution might be correct for the problem in their head. It's just not the problem that's on their paper. So the story can help us, asking the child, what story are you solving? And not rereading it. Can you reread the story, but retelling it? Teachers I've seen will kind of cover up the story with their hand or ask the child to turn the story over. Turn your paper over for just a minute. Talk to me about what story you're solving. There were 8 this and then, that's a different story. The story we're solving today is a little different. It's 6 kids sharing 8 things. Okay, and then, so you get that story? So sometimes it's not that they're doing wrong math. They're doing right math, wrong story. So the story can be a real big support in itself because you can just go back and ask them, where's that in the story? Why can you do that in the story? What's this mean in the story? To connect those quantities. So I'm going to give you some student work. It's 5th grade. It's across the district. I'll tell you a little more about the work later. And I think it's more brownies, but you'll be more creative in your choices. And later, kids need to share things that aren't so easy, right? They need to share liquids. They need to share lengths. So equal sharing problems can be about sharing gallons. It can be about sharing lengths of ribbon or rope. It can be, later it's going to be not just kids sharing items, and we'll look at some of those. So what I would like you to do is in your groups, first of all, just make sense of the kids' strategies and use our chart to help you sort it into the three categories. And then you can sort it into the subcategories too if you want to think about it. And then after you have it sorted, choose one strategy from each of the three to pull out. So one from each of the three groups. Well, one from the first and second group. Just a little bit again about the student work. I gave this assessment to 395 fifth graders, and we only had maybe 2 or 3 that were able to solve it at the highest level. And this was across 5 different schools, 11 different classrooms. So kids really are, when they're asked to solve these problems, really do solve them. It does take some time for kids. So you're not going to see, now that I tell you that, but you're going to choose one from each of the first 2 categories and write a question based on that framework that we looked at to support and extend kids' thinking. And then I'm going to ask you to choose one of the ones that you wrote questions to and put it on a piece of paper, on a chart, and write your questions on the chart, and we're going to post it and walk around and see what kind of questions different tables ask to different kids. So you're going to sort the work, you're going to write questions for a couple of the problems, and then you're going to choose one of those to post on, I'll give you a half sheet of chart paper, post the problem, that student work that you chose, and then write just a couple questions you might ask that child based on kind of the framework we're playing around with. Okay, so any questions?
Oh, yeah.
We don't have to I think we just need to
My daughter's how much
project. You're supposed to know the direction. We're just listening. Jeffrey, we're just And what I'm going to do is I'm going to try to do something, think about something that's going to help me when I get home. To understand what the kids are, understand. You want to do something exact same thing? So 14.
So she just did. So she just that all based on which she There's 14 little brownies, and there's 6 kids. She just broke it up for each kid. Each kid gets 14 brownies. So I'm down to oh, I understand.
Is that right? Yeah.
You see that? I understood that.
Oh, wait.
She does 14. So she does well, she did representative share. Partitioning based on the number of shares. Creates equal shares. So I would say so what are we supposed to do? Yeah, because she didn't identify that there's 6 pieces. She did, like, she represented every share, and if she put a category, yeah, I think so. Yeah, you don't share.
Okay.
She just
Beginning of the year? Beginning of the
she did identify the
So what level are they?
They did 12.
yeah, she did equal sharing.
Take a look and see
And
those.
she didn't do like, okay, I'll give you a brownie, give you a brownie, give you a brownie. She
So
automatically.
the first feature is represents each share.
It's not anticipatory. It's just like, okay, I'm going to give you one. I'm going to give you one.
Yeah, so then that emergent size. But we know what we got to talk about things too, right?
Yeah, no, I agree. That would be it says child partition first item intake only as many parts as there are shares, and then repeats the process for each item. So I don't know if you could say she is perfect, but she just didn't identify.
No, I'm looking.
Oh, no, show us. Well, the first one says child only distributes whole items without it. 2, it says child begins partitioning, so they'll distribute the whole item and then whatever's left over, then they'll partition. And the second one is
I'm doing is I'm writing what's the question that will help them extend. No, I'm not analyzing it. I'm doing that in my head, but I'm writing down a question. I'm not sure if there's any one or right way to look at this.
Okay, so that's what she's missing. So here, what if yeah, so she did that one.
Well, no, you didn't.
So then, but she wasn't able to say, okay, she got.
There had to have souls. It's all
We could say she's like beginning of her vision story, and now she just needs to like identify them.
right now. Put it on.
Oh, yeah.
Well, you just say she asked me, or what's the notice of what they did?
and then come up with the question later. We're supposed to put the question on the paper. Here we're just supposed to analyze what we did.
And they could say,
Oh, that's definitely, yeah, because they just distributed it on each.
So are we all supposed to do all 19?
Same problem.
Do all 19. I already got one done.
Oh, I just literally, you guys just written one down.
No, I think it skips some numbers. It skips 12 and 13 and 15
Oh,
and
it's kind of random. But so are we all supposed to do things that we have this?
Okay, so they did 1, 2, 3, 4, 5, 6.
They were using the same strategy here.
Whatever papers you had.
So am I supposed to do all 10 papers? Who does all 10?
So I would say they're very answers.
Well, no, we were just all doing it.
Is there anything they would do? They should do their explain. I think they did about it. Deciding what they did one time, kind of like still this is maybe decided like a room. That's whatever makes sense. And because you're saying it's like she did that.
I would see it too.
I would say why did you decide to use this and not this? And see what their response was.
Oh, ask him why didn't we divide them up into 6 on each? We could do a picture, why didn't we divide them up?
Why would you divide them up? You guys can hold one.
How did we divide them up?
1, 2, 3, 4, 5, 6 kids. 1, 2, 3, 4, 5 kids. 1, 2, 3, 2. Right on each ground it. 1, 2, 3, 4, 5. See, like, it doesn't, but it didn't use the coordination.
Yeah, it has to be.
Done it in line.
Yeah.
I mean, he did a great job.
Oh, it's not the grass.
We pick up in 7. In 7 guys?
How many people have done this? Like, he made
Or it should be 14. Oh, they get 2 chocolate credits.
How do you know?
I think it's well, what they did was they distributed one each per kid. They're showing they literally distributed. They took a picture and then marked it the same. So I think it's the first one because it says whole items only. Repeated hours or since they took out taking Isn't that the same thing?
But how, I mean, this person is so much. Yeah, I didn't know. See, I don't know. This person. Right, but where's the answer?
And maybe we could sell them that. Oh, I So what are we saying? It's just that this student was unable to.
Well, he actually shared that it was just my time. Try one right. That's really important, right? They show how you are the kids.
Are we done?
We've done 4.
Yeah, that's true. Trial and error. Walk around, check over what scratches.
No, you'd be answering the
Oh, because that's what they did. They said, okay, there's those the 12 balls, cross them off so that each kid got one, and then the 2 that were left split them into 4.
That's 11. Up to 11.
Even though there's one, everyone's gonna get 1, and then saying there's 1 piece left.
You don't think he's split all those in half? Yeah, I was thinking you don't think these are halves, and maybe that's how they're representing it. So half. I think they're halves.
Automatically start.
Yeah.
They start having things.
Yeah,
Because I thought he was checking off like, okay, that one goes here, that one goes here.
Yeah, that's how they would distribute this. Yeah. So I think with him or her doing that, they confuse themselves and they're like, okay, that represents a whole, when it really was meant to represent a half.
He gave them each 2.
And then non-anticipatory.
So I think this is much more like Hannah anyway.
There's only 12 here. Yeah, and then these are 14.
It does a
12 times 2 would be 24, and then 8 would be 32. You would have everything's
I just find that I don't know what it is.
Oh, no, I'm sorry.
that he's kind of chased.
Yeah. So you would get 4, not 3. That's how
Where there's 18 total here.
on the end. Yeah, that's what I'm thinking. That's how he got. But you're saying he should have 4 and he only has 3?
Yeah.
It's like. Because if you did it in half, you would get 4 and 1.
Oh, I see what you're saying.
Yeah.
Maybe that is supposed to be since it's a little smaller than the 1 4. And they just got confused. Oh, I understand what you're saying. So these are like 2, and then it represents that 4.
And the one piece left over is 2.
Left over. Yeah, and like 2.
So they said each one gets 3 and then the last.
Really comes down to what you can afford.
And then if they get 3 from. So he's counting those as those are more like.
I definitely have lots of questions. Yeah.
That's a maybe when you're holding it up, so the camera see what it is first. Watching this, I kind of look at it.
I don't even know. I just think that they had good intentions and then just kind of got lost.
Hey, it's okay. You definitely practice.
No. He just said it
I'm kidding. I just had to say that.
But you're serious. I haven't done what I was ever. Like I've done
So that means
5. No 5. And there's no 12. 6 of
so first he distributed the started without he distributed the
Yeah.
right?
Yeah. And I think Melissa might be right. Like, I think he just maybe thought these would be forced, and then just kind of. And then when he was writing it, it took him 1, 2.
Maybe maybe when he wrote the answer, he wrote everything just said here they have 3 pieces.
3 pieces.
And then but he knew that they were going to get
Yeah.
Tell me about what you said.
Okay. So he didn't take it.
But then I just didn't write.
Things are funny in here, but not funny.
Just me and you. Oh, this is.
How did you telling me?
Oh wow. So they distributed the whole, and then 1, 2, 3, 4, 5, 6, and then broke the remaining into 6. Oh wow. So they will all get.
I thought you were going to say it's all.
Like they started thinking of the number 4, but put the number, and then probably went, oh, I'm supposed to write it out. That's pretty cute.
So they do get pieces, but they're not whole pieces. They get 2 whole,
There you go.
1, the ratio is. So this is 1 6 and 1 6, right?
Did you have to be long?
1, 2, 3, 4, 5, 6. Oh yeah. So what they So what they did was they just did distributes whole items without partitioning.
What you think you want to teach?
And they're just counting 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6.
You ran about on a small high school using improper fractions.
Yeah, if there are, on the repeated tapping, if there are leftover parts of items from the previous rotation by taking them and that's what they just kept on saying. And somehow they got.
Well, I think like Connor said, I mean, each kid gives us one.
Oh, yeah.
Here's one piece, here's two pieces. Here's my third piece, and there's my fourth piece. Like,
There we go.
Yeah.
We're supposed to. I think we're probably one of our
So for the second level, for this one, sorry, hold on, it says sharing one item at a time. Child partitions first item and takes on item. So and there repeats the process for each item. I think we put them in. So child distributes whole items without any partitioning, and then and then wait, so it says if they're leftover parts, they just kind of sort into how much instead of just doing 6.
I mean, I guess obviously it must have been, I don't know why I'm saying he or she. Student number 4. That maybe this person would be more familiar before.
Not every partition is based on 6.
And that's funny, they split it up according to the halves. 1, 2, 3, 4, 5, 6.
So now they took the half.
Yeah. So it just kept getting smaller. Yeah.
I have lots of scripts. 1, 6, 1, 6, 1, 6.
So we know that there's 14 right now. We're getting
Yeah, so they get their 1, 2, 3. What is this? 1, 2, 3. I think that's showing that they would get 3.
I understand. Or maybe they did 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And they said, okay, twice.
Yeah, I don't know where they got the 3.
So maybe they just counted wrong. Maybe they were copying that other picture.
If they were on the right track.
Yeah, they were. So what they did is they took the number of shares that you count, and when it's drawing up the share cutting and we had 6, they just wrote it. Let's say that's how is that going to work? Well, they understand though that it's 1, 6. No, they understand that it has to be cut in 6 pieces, but that's the thing. So they have 14. Why didn't they do 14 brownies and cut it So this is just representing 1%. Yeah, 1%. No, this is representing all the brownies. Wait, that doesn't make any sense. Because there's 1, 2, 3, 4.
Yeah, like
yeah, there's 1.
So if I could just call together for a second, we have our first example up.
So yeah, that's
On the poster, that group has the student work taped on the poster and some questions. And so as you're finishing up, go ahead and grade your poster and then kind of spread them out around the whole room so we have some room to walk. And then we'll wrap up, post things, and take a break. We'll come back at 20 till, so 9:40. Okay, give you some time to finish up, post, and take a break.
Number 4. Number 4.
How did mental strategy involving a general relationship among the number of shares, number of items, and amount of items?
After we come back from break, we'll do a poster.
They didn't miss this number.
Okay, you don't have to poster walk now.
But they just expanded.
I did.
But it doesn't dispute it.
You're the current. That was very
I think it's anticipatory. Just because they were able to recognize, okay, right away, 1 6, 1 6, right away. 1 2. Because if they would have done it properly, they would have gotten 2 and 2 6. But somehow I don't know why they say they were I would just say, so tell me where you got, a question for them. Where did you get that? Or how did you get? Show me 1 2 3. So yeah, we're saying anticipatory. Right? The first one? 6. No, the last one. Oh. Anticipatory. Just because they were able to recognize that it's, 1 6, that relationship would be. Share. I think that one we just did.
Yeah, you don't go.
I think a good question is, is the staple on the side? Or one of the ones where one of the students got 3 could be, are there enough brownies for each person to get 3? Well, yeah, you could say, is everyone getting the same amount of brownies if everyone's getting 4? Because it says everyone gets the same amount. I think everybody does get 4 times. But them putting 4 is telling me that there's 4 equal pieces. That I'm getting 4 pieces that are equal. 4 of the same size. Yeah.
4 each.
So we just took 1.
Yeah, let's do that. A couple of questions you would ask.
Ever. America. Okay, so which number would you guys like to do? You want to do this one? Is one on a grade school game? I think we could ask a lot of questions.
There's one other one.
Maybe this one? This one too would be a good one. No. So we're doing number 4. Because I wasn't. Okay, so Melissa had a good one. Are all 4 pieces
Yeah, you're on the inside.
What made you, why did you divide the last 2 rounds? How did you explain? Yeah. Show me, explain to me the last 2 rounds. How you well, they technically
older than I am because they just kept 50, 52. What? I'm not there yet. So I went to my kids and find out more about
This one here. What you can do, you know what I just can do is just say, just
what does this
report. So how do you really have to say that?
Well, I've already had.
What is like autumn? Yeah, because they obviously just started writing. They just broke it up and started writing numbers until they finished.
What does each piece roughly?
I think so.
I think that's probably
There's something left over when I do it. You want to try again?
Is it piece or? Well, these are. I guess we should say.
Either way, it shows you. Always wrong. You have to
I would just ask for clarification in general. I would just ask them to explain everything. Sometimes I just say, why did you count? Why did you count up to 6 and then go to 6? Just say how this person said, how do we know 8 kids died? Just ask them to explain it. See, can you explain your picture? Because maybe they can self-correct. Or, you just explain your picture. Okay, one kid died, this is he, and then they explain this person. I guess it's the same thing.
We kind of asked, explain or show me the process.
Yeah. I think those are
We just kind of, most people just kind of tape their.
yeah, we just speak somewhere, I guess.
You're welcome.
I had. That's terrible.
That's exactly, that's almost exactly what mine is.
You're so smart.
I was careful with it.
You know what's neat though?
I think the math is
We need something like reference.
You know those people did Yeah.
Your blue cards yesterday. So page 1 is non-anticipatory. It pulls it out on a separate page. It gives you the details at the top. It gives you the 3 strategies that we are commonly seen, and it puts those cards that we sorted the last couple days as examples. So you can say, oh yeah, that's what it looks like. So I skipped you guys. The second page obviously is, well, maybe not obviously, emergent anticipatory, same thing. It's got the characteristics, the 2 strategies and samples. And then the last one is the anticipatory. And there's one other special case down here, and I'm going to show you a video of that later. The reason it's a special case is for 2 reasons. It's called ratio strategy. We haven't looked at that strategy that kids use for equal share. And the reason we're not spending a lot of time on it, not that it's not a powerful strategy that a child can use, but they didn't see it very often. I mean, this is years of research, like 7, 8, 9 years across the grade levels. And there's a reason for that. One of the biggest reasons is you're not going to do a strategy with 7 shared 5, right? There's no common factors. So it's very dependent on the numbers. So we're going to watch a little girl, Maddie, in 5th grade who does it. Also, ratio thinking they found is really not seen very often in younger kids. You start to see it around the 5th, 6th grade. So it's just not the type of thinking that 3rd, 4th, 5th are going to see very often. Even if the numbers, if you purposely put numbers in there that they could cut in half and then half again, or a third or something, and we'll look at the strategy. They just don't see it very often. So we spent most of our time on the ones that are very, very common, and that can work with, that kids use more often. Now, just to remind you of what this is replacing This chart and the little one that's all compact, it's replacing this on page 25. So this was the researchers' original chart. And when teachers began picking up this book and trying to implement it, this was not enough to help support us in the work we have to do if we want to use this way of teaching. So you can see this, handing you this compared to what we've got. And so out of the grant over the last 3 years, this has developed into what you have in front of you. And there's one more year of the grant, so it may develop a little bit more, but nothing's changed as far as the children's thinking. It's just helping us analyze it a little bit better. So it's going to say non-anticipatory, which that's not a problem for us. But you see the next two, additive coordination, one item at a time, additive coordination, groups of items, that's emergent now. It's called emergent. And then the bottom one, the multiplicative coordination, that's called anticipatory. So nothing's changed about how children think, but the names are much more helpful. Non-anticipatory, emergent, and anticipatory. So, so what we're going to do is we have these posters around the room. And so what I'd like you to do is we're going to do a gallery walk. And I'll give you, I'll kind of watch and see how long it takes, but I'll give you probably 10 or 15 minutes. And to just kind of take a look at the posters. You may not get to all of them, or maybe you will. But I have a task for you. So your group is going to go together, and you're going to start somewhere other than your own poster. And you're just going to look at the student work there and the questions that are on that poster. And I want you to do a couple things. First, look at those questions and see if those questions, since we're really trying to practice on focusing on building on what kids understand, see if you can see how the questions that group chose align with what the student has on his or her paper. See how closely the question ties to what the student is showing. And then you're going to take Post-its along with you, and you're going to give feedback to other people's posters. You don't have to do it on every poster, but it'd be sad, right, to come back to your poster and nobody has a Post-it on it. So try and make sure that each poster has several Post-its on it. But what I want you to think about as you post on these charts is, does your group have another question for this same child that you thought was really kind of a nice one that you came up with? So leave it for those guys to think about. Or another thing is, sometimes we have the question that we have in mind. We have it. We know what we want to ask, but what's hard? The wording, right? I know what I want to say, but I can't get the wording right. So if you come to a poster and you see, oh, that's a good question, but maybe if you change the wording like this, it'd be a little clearer to the kid. So those are also good feedback. We like your question. We're also leaving you this way of wording it for you to consider. So you're going to leave a Post-it either for a new question or a different wording or both. And just roam, and at the end of our time, then I'll give you a signal. I don't know what I'll say, I'll probably say signal. And then you'll meet back at your own poster and see what people left you. Okay? All right. Any questions? So grab a Post-it, pad of Post-its and paper, and take your team.
All right, guys.
Yeah, seriously, blow it off.
Are your kids contact work?
Let's go to the poster all the way down. Oh, so she's walking. I get it. She's walking. She's
That's your text. 4 hours. Trying to get say 40 minutes, 4 hours. That's not working. Tell me about your answer and have them try to I would just say, email or explain your answer to me. I would say that they're going to start explaining it and not do it. Where's the one that was all
Oh, yeah.
I love this. Squares between Y's and squares of all the
Her new last name is her sister and twin sisters over it. Those are different. But now that's the one she's at Reagan. That's the one she's at Reagan. She has a twin sister. She talks to her parents.
Because we're meant to show your work and show your work.
And she's going to start.
Yeah, they have all of that.
I almost got brave enough to try it. Sure. I have to split this and make power.
Yeah, just pop this sucker there, and then it's this. This is the one right there, and then over here. And then put it on. You want to do it now?
Well, I mean, I'll try it. I'm not going to do it. Just like flipping you into my bike. Nice.
You have to do your phone.
Sorry. She said go to art. She's on the questions that they
Here's two brownies.
Is Lori Benway here?
So as you're working your way back to your seats, just a little bit more about this assessment. So these were all from 5th grade classes, and we offered a training. We were a year-round school district back then, and so you ended school, and if you were A or C track, you started 2 weeks later. So in that time, we just invited any 5th grade teachers who were interested to come learn about this research on how kids think about fractions. And so we had a small group of 5th grade teachers from our district. And at that time, our district was looking into CGI, and a lot of teachers began to say, we had a benchmark assessment. I don't know if you guys ever went down, if you do benchmark assessments. But, and teachers got to, invest some time in building those assessments. But some of us were saying, the benchmarks, our kids may not do very well early on in the benchmarks because we are kind of building on kids' thinking rather than, kind of following the textbook. And so, but at the end of the year, we expect our kids to be, just fine, and the last benchmark should show that. But is there a way that if we're invested in this research and want to teach in this way, can you support us a little bit with assessment? And so our district said, if you can come up with another assessment that shows growth, so that teachers don't get to the end of the year and say, whoops. And so we got together and said, okay, and came up with an assessment. I'll show you the tasks we're going to give kids. And we were going to give the same tasks at the beginning of the year, and then the same identical problems, just a few of them, 3 months later or so, and then again 3 months later, and then kind of towards the end. And each time we were going to do that, we were going to sort the kids and put where they were in their level of strategy. So if I was non-anticipatory 3 months later, given the opportunity to solve more of these, not like, well, you haven't done any equal share, where we should begin to see kids move. And so we were able to see, hey, 3 months ago, they were non-anticipatory. Some of those kids now, with some numbers, are emergent. Some are even with some numbers, fully anticipatory. So we began to look at that. So I'll show you that assessment. And so many of our schools took that on, and each grade level came up with what are 3 big ideas in your grade level that no child in your classroom is going to leave without having a full, a solid understanding. And they wrote a few problems, and they gave those problems several times through the year. So this is another thing you can do, is you can, come up with, as a team, come up with, once you see the other 2 problem types, come up with some problem types. Think about the stories and the numbers that we can start at the beginning of the year, but then give continuously throughout the year, 3 or 4 times, to see growth. And kids can see their growth too, which is kind of exciting. So I wanted to share with you this one strategy that is on the chart but not discussed very much, because it's really dependent on numbers and age. And that's the ratio strategy. So this is Maddie. Maddie's in 5th grade, and her teacher starts with the kids on the rug. They talk a little bit about the problem, and then the kids go back and solve it. And I'll stop. I'll turn this down so you can see. I'll stop. You kind of need Dramamine just at the beginning, and it wasn't me. So I felt much better when I saw somebody not get the camera steady quite as quickly. But this is Maddie, and I'll stop along the, at the beginning so you can see and talk about what she's done. Here we go. 8 people. So she split the number of cans in half and people. So her first cut was not cutting up the bars of clay. Now, she made a new problem. What's the new problem now she's thinking about? Yeah. So 8 kids sharing 6, I can think about a simpler problem as 4 kids sharing 3. And she could solve it from there, right? But she goes further with a simpler problem. So what does she do next? She does it on both sides, right? So now I have to cut a bar in half because there's 3, but the people don't have to be cut in half because can't do that, right? So what's her problem become now? So it was 6 cans, 8 kids. then it was 3 cans, 4 kids, and now it's 1.5 cans. And that's the problem she finally solves. What does she do from there? So I'm still not down to how much one person gets, right? So my goal is to get to one person. So she splits, they each share that. So one of the kids gets this and one that. And she splits the half and the fourth, she says. And so everyone gets 1/2 and 1/4, and she thinks for a second and says that's 3/4. So, so a little bit different strategy, but it's not one they see very often. But it's nice to kind of, I think it's kind of fascinating that how do you know you only have to solve this and it's the same as 6 kids sharing 8. I mean, that just feels so, you can feel the weight of the, what am I trying to say, the cognitive the level you have to kind of be at there. To be able to understand that I can create a whole new sharing situation, but yet it's going to end up the same amounts everyone's going to get. So 6/8 is the same as 3/4 is the same as 1.5 halves. I guess that would be right. 1.5 halves. So that's what the ratio strategy can look like. Question?
Okay. So we noticed that all the kids were using very similar strategies. How much instruction did they get before you gave them?
Guys?
Yes, the kids on the wall.
Not much at all.
Really?
So the teachers they've come from, it was started, teachers would have had a couple weeks before I got into the classrooms. Oh, sorry. Teachers so they had come to training, school started up right afterwards, and I told them we were going to be doing a pre and a post, and then my job got changed so I could never go back and do the post. But the kids had not yet gotten much training at all. But remember, in the old California standards, because this is about 5 years ago, 6 years ago, when did fractions start back then? 2nd grade. It started with color in, 1 out of 3, and we know, we'll talk a little bit about that kind of instruction and what kind of meaning it builds in kids. So these kids had fractions in 2nd. In 2nd, I remember the 2 content standards for 2nd, because I was a 2nd, 3rd grade teacher. It was know what a unit fraction from 1/2 down to 1/12 was, and that for 2nd. And know that 3/3, 4/4, made a whole. So it was those 2 that are huge ideas and can often take a longer time. Went to a 6th grade class and just wanted to know what kids knew about fractions so we could kind of get a feel. And we asked them, it had been a pretty traditional site, and we said, what do you guys know about fractions? Don't worry if you think it's right or wrong. Let's just put out what we think we know. So they started telling us things, and one little guy said, well, I know 4/4 is 1. And somebody else said, and I'm not going to get the numbers right, but you'll get the idea, well, 7/7 is 1. And you know what happens in 6th grade. 127, 127, 1,560,000. We didn't have Google over a Google, which would have been fun, right? But the teacher put up this equation. So, true or false, you guys? Class was silent. So kids are constantly telling us, we understand some things, but keep asking us, because they're still learning to be done. And so they knew some things, but there was still lots to talk about that year. just by asking questions. I loved a couple of you when I was walking around, you were saying, well, we have to ask kids questions about their work. So, I mean, if we take that back with us, that's huge. That the answer or the picture even only tells us so much. So, but I never got back in. But I was very, we got great work from that we could use in PD. But what I did is I went to every single classroom and I passed out the assessment. There were 6 questions, I think, 2 equal share. I'll show you the results a little bit later. And I talked through the problems with the kids. We read them out loud, any questions, and then they had a certain amount of time. We didn't time it. And they could call me over, but all I would do is help them understand the story. So I would say, like, remind me of the story you're solving, and help them, you know, get their mind wrapped around the story. But I didn't suggest any strategy. There were a few kids that I would say things like, if they weren't starting, is there anything you could do? What do you think, how do you think you might start? And if they said, well, I could draw a picture. Okay, go ahead. And then I would walk away. But I didn't give them any suggestions. So, and kind of wanted to control it so we knew exactly what the kids were doing. Okay, where are we here? So, when we take a look at this idea of equal sharing, what do I want to do first with you? I think I want to do this first. Hopefully we got to begin to see that these problems could really potentially be a powerful place to either introduce kids, if you're in 3rd grade, especially it's kind of the introduction, although fractions go down into 2nd. They're not, 3rd through 5th have the name fraction on their little strand, right? But looking outside of 5th and 3rd, you can find it other places. But a powerful way not to only introduce, but to let kids that maybe have been introduced to fractions in a different way, maybe have a chance to come away with a different understanding. So it can help kids develop this conceptual understanding, and at the same time, built in that the practices of mathematics. You don't have to design a lesson to meet mathematical practice number 3. That often with just in real problem solving, the processes naturally come out. You might want to focus on one or be more specific with one, but hopefully you saw that the mathematical practices just naturally come out, often come out. So I don't want to spend a lot of time on kind of the traditional techniques or the ways traditionally fractions have been taught, but it is kind of nice to think about. Traditionally, and I don't know textbooks how much they're changing, but traditionally I know in 2nd or 3rd grade this was often how fraction would start. So color in, right? Color in fractions. So color 1/4, and so on. So often kids got a lot of these kind of worksheets, or I found lots of them in teacher supply, and I ran lots of them off and gave them to my 2nd and 3rd graders, and before. We'll see in a lot of pie kind of shapes that were pre-drawn, and kind of definitions. We call the top number the numerator, and it's the number of parts, and the bottom the denominator. And then I was the queen of manipulatives when I first started teaching. You'll know how old I am now. Base 10 was the brand new thing. And we were trained on how to use base 10. Anybody remember the long strips? Anybody old enough to say they remember the long strips? And you told kids you put that over here and you put a 1, and you put this, and then you get 10 and you put it over here, and you move the 1 over here, and then you, so, and we had very strict training on how to use those manipulatives. Because we thought wood pieces could teach children. And now I giggle about it, but hey, I didn't know. So I don't beat myself up anymore. I was talking to another teacher in here that said, yeah, I've been teaching in a way that I didn't know, maybe wasn't always giving the kids the opportunity I wanted to give them. I said, you can't beat yourself up on that. We do the best with what we have. So especially when the styrofoam pieces came in, man, those were, I was loving those, because now they're quiet, right? So we had the little kits that came in the little, And so my third graders, we got these. I said, okay, spread your tables out. Everybody get on the floor, get in groups, and let's make one as many ways as you can. So I was walking around, and kids had their pieces and doing some things, and I would look, and I'm like, how did they make one? They only have 7 greens, or whatever the color was. So this one, they only have 7 oranges, and they're saying that's one. But those are these. So I would ask them, but it looked like a circle, right? So how many oranges make a hole? 7? Well, no, there's supposed to be 8. Well, it's making a circle. Well, where's your 8th one? What 8th one? Then I turn around, guess how many oranges were in this hole? 9. And it still looked like a circle because third graders don't care. They'll squish it in or they'll, it's faces. So what's going on? Why isn't this working? And I could never figure out what else to do. And when I saw this, it was like, this is it. I think this has potential, what we're doing now. But what we find kids understand, come away, the type of understanding they often come away with are these kinds of things. You may have heard some of these in your classrooms. That fractions or pictures or colored pieces. I have a high school teacher who asks her kids to draw a fourth every year. These are 9th, 10th, and 11th graders in algebra. And they have algebra and then they come to her for a kind of fill in the holes. And so she asks them to do 2 things. Represent 1/4 and show a picture of 5/4. And out of her classes, only a handful can do those tasks. And often this is what a 4th is to them. And 5/4, well, you'll see that. So that fractions are colored pieces as opposed to numbers. And so gives us a good indication of why kids struggle putting fractions on a number line. How do I put that concept of a fraction on a number line? Or that fractions are brand new ideas. I heard somebody over here talking about that has nothing to do with what we've already learned. Instead of, hey, yeah, it's exactly like what you've been learning with division with whole numbers. We're just now doing division where we get to break, keep dividing wholes up. Or that fractions are always less than 1. I've even heard kids say fractions are less than 0. So 5/4 is impossible, because how could you have 5 out of 4? And drawing it is kind of difficult. So sometimes this kind of instruction can often lead, we're finding, to this kind of conception. That fractions are out-ofs. I think you saw it in a couple of kids' work where we were just counting pieces. So there was no kind of relationship to the whole. It's just 1 out of 3. So that would be 5/8 to them, right? Because it's 5 out of 8. If you rename the whole, so what they're finding when kids use discuss equal sharing problems, through this context, they come away with a different kind of understanding. So in their solving, they learn that wholes can be partitioned into parts, and that's what they're doing. That parts are related to the wholes. We call this 1/4 because there's 4 kids sharing it, or there's 4 of this size piece in the whole thing. That unit fractions are the building blocks for all other fractions. So if I have 1/4 and 1/4 and 1/4 and 1/4, I have that many fourths. That they're related to division because they're solving a division problem. That's what an equal share is, a partitive division. And that they're numbers. They're not a 1 out of. They're a quantity itself, and they're learning that they're bigger or smaller than 1, or bigger or smaller than 3.5. And so I can put 3 1/2 on a number line. I can put 3/4 on a number line if I'm thinking about what 1/4 is and what 1/2 is. And that fractions are numbers that fill in the whole number line, which is freaky, keeps me up at night. I'll show you the graphic that keeps me up at night. So relationally, this is kind of what it would look like more symbolically. So they're learning that if one thing is divided up among 4 people, everybody's share is 1/4. So this is what that story would look like symbolically. And later we can introduce them to the symbolism. Like you guys said, let them get the concept down. And then we can say, so you took one thing, divided up among 4 kids, and so each person gets 1/4. I'll show you, Andrew, because that's a nice example. That parts are related to wholes. That goes the other way. 4/4 gets me back to my whole. There's what the unit fractions are building blocks. And this comes down to a fundamental big idea in mathematics. 1/4 plus 1/4 plus 1/4 is not 3/12, right? Why not? Okay, don't use a definition on me. Use something other than, because the denominator stays the same when we add. I'm going to push you. Use a, why isn't it 3/12? Right, so these are the same size pieces. So the big idea in mathematics is we can only add the same size things, like units. And so when we have 2 10s and 3 1s, we don't have 5 of anything, right? Because we can't add different units. When we have 1/4 and 1/5, we don't have 2 of anything. When we have x squared and 2x, when we have 2x squared and 2x, we don't have 4 of anything. So the big idea that like units is the only thing that we can combine together. So these happen to be like units. 1/4 and 1/5 are not like units. And that fractions are related to division. And that's kind of the end goal. That's, I think, in 6th grade. That we can say this is true. And it's not true because that bar represents the division problem. I mean, it is, but it isn't. These two ideas are equivalent ideas. That this expression of division represents this quantity of a number. I think that's a big deal. It is for me. I still think that's like, yeah, I can tell you, well, that line means a division sign. But to really realize that this operation and this number are the same thing, it feels big to me, my little brain. And that they can fill in the whole number line. So between any number on the number line, how many other numbers are there? Why? Because we can keep cutting, right? Because we can keep cutting like they're doing. They can keep cutting. And that's just freaky. How can't... It seems like between 2 and 3, that's an infinite amount of space. But there's an infinite, or a finite amount of space, but an infinite amount of numbers. I can't stay on that too long. I get freaked out. Right. I don't think I'm going to show you. So what we found is kids come away with different understandings between more traditional problem solving and problem solving using equal sharing to introduce and to develop fraction concepts. So I want to spend some time letting you guys think about this idea of where do I get my problems? So teachers who teach in this way, they will do a couple things. They will strategically select or adapt prompts from your textbooks or other sources that you have. And so you may find one that's just perfect the way it is, or you may find one that you like the idea, but you're going to change the numbers because you know a little bit more about where your kids are. But often, they often generate their own equal sharing problems too, kind of what you guys said this morning, to fit what my kids are interested in, put their names in it. And often there's just not enough problems in a book. That takes a lot of problems for us to develop deep understanding. And sometimes it's like, well, they have 7 problems in the book and they want them to get from here to here. That's just not enough. So often we need to generate our own. So your book is going to have some support for you. So if you went further last night, after the equal sharing chapter, I want us to take a look at the resource. Thank you. Starting on page 29. It's So page 29, 30, and 31, you're going to see there's some sample equal sharing problems. And generally, they're arranged according, numbers make all the difference, and we kind of begin to see that. So they're generally, the numbers are easier to more difficult. So you can see we're starting with 2 sharers or 4 sharers, or, and then 3 kind of gets worked in, 8, 6, 5, and so forth. Why are 10 sharers important to give kids? Base 10, what else? What are you going to get if 10 kids share something? Tenths. So it's the introduction to the fraction representation. And often it's kids, a fraction, 1/10 is easier sometimes than the decimal representation. But you can introduce them to what a tenth is, and they can count tenths, and they can get 11 tenths, and know it's 1 1/10, not 0.11. So I slap people who say point now. No, not that hard, but I do slap people. Not hard, I promise you, not hard. And I like to share things teachers have shared with me that have been kind of profound, and this was one of them. This was a high school student who had down this. So we were asking her about it. So tell us what you wrote here. And she said, well, 6 over 12 equals 0.5. Well, how do you know that? Or no, can you say that a different way? 6 over 12 equals .5? And they're in high school, and you're like, how do I help get you started thinking about this? So your heart just like aches for them, because you know she had good teachers, but our instruction we know we want to consider all the time. So I asked her, how do you know that? And she said, well, my teacher said that this is equal to this. Okay, so how did you know this? Well, 5 is half of 10. So that's 0.5. 6 is half of 12. Oh, I'm sorry. I said the wrong thing. So that's 0.6. You're probably going, Joe, what's wrong with that? So 5 is half of 10, so it's 0.5. 6 is half of 12, so it's... So this would have been what to her? So, I think, yeah, understanding 1/10 what it is and using 1/10 way, yeah, eventually point is fine, but she didn't know anything about what that was meaning. So as we think about problems for our classroom, maybe considering that we use problems to further our goals to help specific children grow. So by thinking about where our kids are as we let them solve problems, we can begin to strategically choose problems to help kids grow in particular ways rather than cover the content. So we see when we pose problems to kids to help them grow in particular ways, the content gets developed. So it's a way to think about using where kids are, building on what kids understand to develop the content rather than kind of vice versa. So I want to give you a chance to play around with problems. And so I have two that I want to kind of get you started on, and then I'm going to give you more flexibility. So what I want you to do is I'm going to give you 2 scenarios. I will find it. I laid it out. 2 scenarios. The first one is going to be, that's not the one I want. I'll go with the directions and I'll find the one. I switched it because I learned things from you guys, so I switched things in the evening. So the first thing you're going to do, and you can start it before I pass you out the paper, is if your mathematical goal for your kids is to get them engaged with thirds. which of these problems would be a good choice? Problem or problems? Okay? So think about how kids are going to solve it, and talk at your tables and make sure you're thinking how kids do, and see which ones may or may not engage kids in the kind of math you want. It's not the age. Well, here's a good start kind of to think about. When would we want to engage a child in thirds? Once they've got the halves and fourths. Maybe I've given them enough equal sharing problems with 2 kids, 4 kids, 8 kids, and they need to be pushed. I've let them solve problems where halving was possible. But now we need to push it. So now I need to figure out what problem is going to make them do thirds. Because that's harder.
Try it. Solve them the way kids would. Mess around with it. Find out.
I'll give you 1/3.
Were you guys in the 900s? Thirds, 2 whole numbers divided into a whole. You would be more confusing.
Once you get D, yeah, all the way to 2 brownies. 2 brownies. And then split it with
Yeah. Size up from
Do you get what I'm saying? It's like they're fried.
Yeah, they're just one piece.
But I told you.
Just do the first page. Don't worry about the other pages because I have something different I kind of want you to
You like it? So now you're making it confusing. I want you dividing it into three.
We got 30.
Yeah. Gotta take down now.
I bought
I get one, you get one, you get one. I get one, you get one, you get one. That's like 2 each, and then you guys figure out how much of each. We have 2 left.
No, I haven't. No, I haven't.
Yeah.
like right now, so like.
So which one? Letter A?
I guess,
Well, yeah, that's what I'm saying.
Yes.
and most everything I heard from
I was thinking my master already. It was like, well, but then I would take 75 minutes of
D is the dog. Yep. That's right. Other than do
Some of them, it may depend on the kid's approach, whether you get forwards or not. Do you reject it? Yes.
I didn't look into it. Share.
So again, it depends on how the kid's approach.
We already had if you're thinking,
where I have like, you know, our names, and then our names, like, your whole names. Oh, see, I was not older, so that was nice. But I had like
That's
We did 6, we did 3 each.
So I petition for a certain one. Which ones did you think would be good choices? D? So talk about why D. Through how we know kids think about these. Why D?
I think it's the choice for kids to either pull out the holes.
Hold on, sorry.
I think D gives students the option to either pull the holes out first and then partition the remainder, or go straight to splitting each of the 8 into thirds.
So they have an option of passing out the holes, which is easier for kids.
Right.
And then what?
And then partitioning the remainder into thirds.
So they have 2 things, and dividing it into thirds, that's if you're not thinking about it, you're not anticipatory, having's not going to work, right? It's never going to work. You're going to have to never repeat having's never going to work. So it's going to force them into having to think about another type of partition than a having to use. What about another one? Let's look at, let's go up. How about C? 4 children share 3. Why?
because it's a quarter.
But there's a 3 in the story. It's not going to make sense if 4 kids. I would never go to going.
You're breaking it into 4 pieces.
So naturally you're going to do this. 4,000. So how about B?
Share out the first 6, and then you've got 3 left over.
Share out the, and then you have.
Our havers aren't going to be challenged here, are they? We want to be challenged. So that one, E, you're going to get away with doing the same old and not be challenged a little bit. Okay. So how about A?
It is possible, but you have to have your equivalents in place in order to do it with A.
They're going to have 6.
They might end up with 6. What else might they end up? Why? Why else might they cut it up into thirds? Keep going. Yeah, 3 plus 3. That 2 may be sitting there, even though it's 6. That 2 sitting there might be a lot easier with 6 kids than with 3 kids. So if I've got this and you're telling me 3 kids have to share that versus 6 kids, 6 is feeling a little easier to me. I might have my doubles that will help.
So how, is it way off the chart? Why are you laughing? What did I do? To entertain you. Okay, there we go. So, so how did we know? How did we know what challenge or what might be easier or harder? What's going to kind of, we didn't just look at the numbers. Looked at how kids are going to solve it. Right? So we have a mathematical goal in mind that our kids need to, a group of kids or a class, I want to get them the challenge to do something other than having. So play them out. Play with some of the numbers and see which ones might be obvious to kids. And the 6 sharing 2 might be more obvious to go to thirds than 3 sharing 2. So I wanted to give you an experience kind of feeling about how number choice. So another thing we looked at with equal sharing, it not only builds what the fraction of a concept of what a fraction is, a unit fraction, but also can be used to develop equivalence. So I want to give you a little bit of time to think about how equal sharing problems can help you engage kids in discussions around equivalence and around specific equivalences. So I'm going to ask you to do the same kind of thing, and you can work through them any way you want. Choose one that's interesting to you, or start at the beginning. It doesn't matter. But get you again too. But what I want you to think about is that we can. There's several places where we can engage kids in discussion around equivalence. So you see at the top that there's an opportunity for discussion around equivalence between two strategies. So if one child has 4/5 in his answer and one has 8/10, we can have a discussion, are those the same amount? So we can look for equivalence in two different strategies from two different kids. We can also look at equivalence between parts of two strategies. So you said everybody gets a half and an eighth. You said everybody gets 5/8. Where's the 1/2 in the 5/8? So we can look for equivalent discussions in parts of two strategies. Or within one kid's strategy. You got 1/2 and 1/4. I wonder how much that is altogether. Another thing you might want to write here that I've seen is really powerful. Teachers will say, so everybody gets 1/2 and 1/4. They get 1/2 of this brownie and they get 1/4 of that brownie. Could you draw the 1/2 a brownie and 1/4 of a brownie in one brownie? Could you show what that would look like in one brownie? And that's a really powerful question too. So it can be between two strategies, between parts of two strategies, or within one child's strategy. So these are some examples. So there's the problem stem. This many children want to share this many oranges. And so on A, for an example, which of these numbered choices, and maybe one, maybe more than one, which is likely to lead to a discussion of whether 1/3 of an orange and 2/6 of an orange are the same amount. So I want you to use what you know, how kids would solve those problems. What pair of numbers would you put into that story if your goal that day was to have kids talk about why 1/3 and 2/6 would be the same amount? Once you think a pair of numbers will work for that discussion, make sure you support it with student thinking.
The first number represents the number of children, the second in the ordered pair is the number of items.
Just because there's a word doesn't mean you can't say it. That's 2 6s. It's really likely. 3 and 4 if you ask the right question. Yeah, 4, 6, 4. Ask the right question. Oh.
You have to do children first, or do you eat?
Oh, we can.
No, you're right.
6 and 2. Did you get 6 and 2?
Then I'm
6, 6. Just that one.
Everything else comes up even numbers. 3 and That was really okay. Well, it worked. He did some practice. Oh man.
Has everyone gotten to think about the first problem? So I hate stopping you in the middle of a good discussion, but I want to be able to play a game before we go to lunch. 2 games that I want to share with you. And maybe the other part of the back, if you haven't gotten to it, maybe you could talk about that at lunch or for homework too. But if we can come back together for just a second to share what we're kind of thinking about or learning how to choose numbers for specific mathematical goals or discussions in our class. So if we are looking at this first one, is the equivalence, we want to get a discussion going around, are these 2 fractions equivalent? So how about 3 kids sharing 8? Oh, thank you. Gotta watch me every second. So how about that one? That gonna do it? Well, kids are likely to pass out goals. They don't have to, and it's lovely when they don't, because we know other math can come out of it. Then what happens? I'm going to split these in, maybe I'm going to split these into thirds. If I'm a haver and I, haven't had that experience, that's going to be tough for me. So the havers is going to be tough. So I could get 1/3 here and 1/3 here. Would I ever see a child split it into 6? Why? There's no reason to. It doesn't make sense to do that for this one. How about 3 sharing 4? Same thing, it gets us just the 1/3, that's a nice thing, right? But it doesn't get us anything about 6. 4 sharing 3? No, right? I'm not going to cut it into thirds or 6. If there's 4 kids, that would be a lunacy, right? So 6 sharing 2. So why? I could cut it into 6, and it's nice to watch how they cut it into 6, because you can slow it down. Wait, slow motion. Watch how he cut it into 6. What did he do first? Thirds, and then how did he make 6? He cut each of the thirds in half. So you can slow it down. Where's the third again? Where's the 6? And so, person that did it like this, every kid's going to get 2 6. How else might kids do it? Yeah, because we know we have the shared groups of items. Here's our emergent anticipatory sharing 1 item at a time. Here's sharing groups of items. So because the kids' strategies are so diverse, it allows us to teach the math we need to teach. If they all did it the same, we wouldn't be here talking about anything if we all thought the same. So then everybody gets 1/3, right? 2, 4, 5, 6. How about the 8 share 6? No, we don't need to go there anymore. How about 6 share 4? So I'm going to cut everything into 6ths, right? Kids start doing this, especially if you do 12 kids. And that's when you want to capitalize on it, right? Because they're almost not needing those pictures anymore. So they'll even ask you, Mrs. Case, do I have to cut them all into 12s? I don't know. Do you need to cut them all into 12s to know how much everyone's going to get? No. Why? Because there's 4 of them, they're going to get a 12th out of it. All right, let's see how we can put that down so you don't have to cut them all into 12s. So when you see this, that's when you want to go do a little jig and kind of hang out over there and talk with them. So they're going to cut it all into 6, so everybody's going to get 4 6. How else might they cut it? Might take 2 of them and share with the 6 kids, right? Kid 1, 2, 3, 4, 5, 6. I'm being messy, I'm sorry. Kid 1, 2, 3, 4, 5, 6. So now we have 4 6 compared to 2 thirds. So you could find it in there, but where is it easiest to find it? What's this equivalence going to be, though? Equals 2 thirds. So you can see just by leaving 2 items, you're going to get more specifically what you want, and you can see the relationship here. When you want to compare, but this lets you compare that earliest relationship. What's the earliest relationship here between thirds and 6? Let me draw it again really quickly, sorry. So over here, I'm getting 1/6 out of this and 1/6 out of this, and over here, I'm just getting 1/3, right? Kid 1, 2, 3, 4, 5, 6. Kid 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is that earliest relationship where I'm going to just look at a unit fraction, because that's what they're all going to be built off of. And so often books will, we know how equivalence is often taught, where you multiply, right? But what's the relationship between thirds and sixths here? So I could write this, but what would be another way to write that to show the relationship? Yeah. So I just want to put that out for you to consider. We often see it like this. But this, when the kids say, well, 1/6 and 1/6 is the same as 1/3, this fundamental relationship written this way versus this way shows a double. That's harder to see here. Yeah. And so they eventually begin to understand the relationship that they probably don't always understand, up here. But showing it as unit fractions is kind of nice. So what's the relationship between 1/3 and 3/9? 1/3 is the same as 1/9 plus 1/9 plus 1/9. Now we can talk about how many times larger. So I just want to throw this out because we're messing around with it to see if this supports kids in a different way than this, and we're finding some really nice benefit of when kids start saying, well, it takes 3/9 to make a third, that we write it like this. So you need 3 of these 9ths to make a third. So that it's not always double. Sometimes there's a 3-to-1 relationship. Or a 4-to-1 if it's 12 and thirds. Did I get that right? Okay. So you guys have worked hard, and there's a lot that you've had to think hard about. But I hope that gives you a little exposure to how to think about combining what we learn kids do to solve these problems with our mathematics and how to select numbers. It's all about number choice. You can create just real creative problems, and just by choosing the number choices. And that's where direct teaching comes into me. I see it in a different way than I do, you do, we do kind of thing, where we are totally in control. I'm in control of writing a story, choosing the numbers, thinking about the questions I might want to ask, who I'm going to share, what mathematics I'm going to bring out, how I might notate it. The only thing I have a lot of control. But the only thing I'm not going to take control over is the child's thinking, the problem solving. So, so it's not saying we're just standing on the side and letting this fluffy math happen. We created the problem for a specific reason. We know where our kids are. We want to push them. So there's lots of directed teaching in the way I think about it now that builds on kids' thinking. So are you ready for a little bit of a game before we go to lunch? We need a little break of a game, right? So some of you may know one or both of these activities. And if you do, be a good facilitator and let others who maybe don't know play around with it a little bit before you say anything. But have you ever played the game, which one doesn't fit? So here's how the game goes. So there's 4 numbers here. And at your tables, I want you to come up with which of these 4 numbers doesn't fit with the other 3. And there's more than one answer. So see how many ways you can think about which one doesn't fit.
Not a multiple of 5. 49 is a 50 square. $70 doesn't fit.
Is there a way to make all 4 of them not fit? In each one not fit for some reason.
It's a So 70 is 50. It's above 50. It's above 50, so it doesn't fit. We have 4 things so far. It's 10.
No, she's not. You liar. She's the liar.
Just for that. Sevens and fives. 49, 35, 70 or 70, and then 5 would be 35, 70. 70 is okay, 49, 50.
Oh, yeah.
Okay, does anybody want to pick a number and tell why it doesn't fit? You guys want to start?
So if you add the digits together, 35 is the only one that would be an even number, and the rest of them would be odd.
So she said 35 doesn't fit. Why? That's not what she said. Want to hear it again? That's a nice thing to give to kids too, right? Want to hear it again?
Yeah, now they did. Not that they weren't, but they were busy with their.
If you add the digits together, 35 is the only number that would be even. 3 plus 5 is 8.
Okay. So Uh-huh.
We have one.
Yeah, what? So everybody understand that, so if you add the two digits together, 35 is the only even number, 49 would be what? 13.
I'll just talk loud. 49 is the square number.
Hey!
Oh, what's a square number? What do you mean?
It's a square.
Makes a square, 7 groups of 7, we can create a square out of it, okay?
35. 35 is the only one that has a multiple on the board. 35 times 2 is 70. None of the rest have a multiple.
Ooh, that one I didn't think of.
50, because 49, 35, and 70 are all divisible by 7.
Yeah.
49 doesn't fit because if you flip one of the digits upside down, it becomes 46, and none of the others do that.
Yeah, I know what kind of kid you were in class. We got you pegged by that. Well, this sounds like it was a little too simple for you guys. Oh, nobody picked 70 yet. That's right. Somebody got to 70. Ah.
It's the only number greater than 50.
Only number greater than 50. The only number I haven't reached in inches, is that what you're saying? That's you. Okay, let's up the challenge a little bit. You can tell I did it last night at the Holiday Inn where I'm staying. So it was late, so maybe that there was mistakes here. But see, and I don't know. I'm not talking anymore about my Holiday Inn experience. So see if you can figure out which one of these doesn't fit. And I'm gonna see if you guess the one that I was really the one I was trying lots of things, but one I was quite proud of myself for coming up with.
6/10 is the only one that can be converted easily. Well, I think that 6/8 can be depends on which.
Yeah.
And 2/3 don't hit because if you convert them to decimals, they're repeated patterns. Or 6/10 and 6/8. So now they're so we only have 2, right? Can't find less than half. 6/8 is the largest one.
It's the only one.
It's chance because when you put it to decimal form,
It's the only one that equals 3 when you invert it. .667, but you rounded it. So it's a repeated pattern. 2/3 is a repeated pattern. 2/6 is a repeated pattern. 3.33.
Does anybody want to try one?
yes.
2/6 is the only one less than half.
And then what would we want to do with that with our kids? Prove it, right? Don't let them get away with just saying that. You got to prove it. So Connor, sorry, you got to prove that to us. It just is. So even in games, we can get our mathematical practices in, right? We never have to stop asking, we should always ask, how do you know, or prove that to us. So anybody want to prove if they agree with Connor or not? He said, Connor said, you said it's the only one, 2/6 is the only one less than half?
Is 3/6 half and 2 is less than 3?
So you prove that 2/6 is less than half because 3/6 is half?
You could convert them all to decimals to prove that 2/6 is the only one less than 5.5.
Could go to decimals. The others have to be more than half, so you could see where the kids could talk about 5/10, 4/8. What about 2/3? Is that more than half? That'd be a little harder to prove, right? So you can put one in there that's a little harder to prove. How much more than half is it? 1/6 more. Do you remember old Roger helped us with that one, right? Yeah. So this is kind of a nice game, and you can make it as easy or as challenging. You put decimals in there and any kind of number, mixed numbers. So there's one other game that I'm going to have 2 people volunteer to play, and then I'm going to give you a chance to come up with one that you might do with your kids. So you guys get the Scholastic book, people that come in and they roll in the big medals, right? They open up and the book fairs. And so they always bring teacher things with them. And one year, years ago, I found a Scholastic teacher thing in the book fair, and it was just math games. And I like simple. I don't like we have to have a lot of pieces, or just pick up a piece of paper and do something on it. So there was one that was a counting game, and it was kind of cool because we in our district, in our school, in our grade level, 3rd grade did a lot of counting. And we found that counting was really important for kids, and often it stops after 1st or 2nd grade. And since then, UCLA has done a huge project around counting with children, starting in preschool and kindergarten. And that counting is the beginning of measurement. And that counting should never stop. And they're encouraging even high school math teachers to count on a regular basis with their kids. So there's different ways you can do it. You can have a journal, and we'll talk more about that. But we found this game, and we're using it before that research came out, so we were quite proud of ourselves. But the game was very simple. It's a partner game, so it takes 2 people. And all it takes, and there's no magic to the number of lines, but the book had 20, and 20 worked, and so there's 20 lines. And I just did it on my computer. And I cut it into thirds, sent it to the print shop, cut it into thirds, but you don't have, you can do it on, the tag or whatever the cheap newsprint is. So there's 20 lines, and so you get to, or you could turn it over to the kids too and see what they come up with. So there's, you get to choose where to start, which direction to go, and what to count by. So today I'm choosing for 2 people to start at 120, to count forward by 35. Okay? So we're going to start at 120, we're going to count forward by 35. And it's going to be a partner. So I'll have you do that. I'll have you do it with a partner. Now, you have to have a winner, right? So the winner is the one who gets to write the last number. And there's one more rule I didn't tell you about. When it's your turn, it goes back and forth, you can write either the next number or the next 2 numbers. So you get a choice. When it's your turn, you can write the next number or that number and 1 more, but you can't write 3. And the winner is the one who gets to write the last number. Okay? So find a part. Should we have somebody do it? Come up and do it? Let's have 2 people. Who wants to come up and 2 people come up and do it? Come on. You come up and do it. I will. Come on. I'll repeat them. I'm a teacher. You know how to repeat directions over and over. So somebody else. Somebody else want to come up? Come on. I'll let you go to lunch 37 seconds early. Yesterday. Don't forget, 37 seconds over. Now, when I played this, sometimes I had the kids, they always had colored pencils or colored pens. I had them play in different colored pens, and I had them write their name on the bottom in the colored pen. So if I collected them later or looked at them, I could tell who had written what. So you can manage it however you want. So okay, so you're going to start at 120. So you can go ahead and put 120 up there. And that doesn't have to be your turn. And then we're going to count forward by 35, and when it's your turn, you get to write one number or two numbers. So you can do rock, paper, scissors, or whatever you want to decide who gets to go first. Oh, okay. Oh. So you can write the next number or the next two numbers. It's your choice. Counting forward by 35.
Can I do as many as I want?
One or two?
One or two. Oh, to clarify.
Winner. If you want to do all that work, you can be winner.
It's a Sonora game, right? I know. Tom taught us this, right?
So that's a good thing. In my class, we were a kinder, gentler class, and so if you get it wrong, you know, I just said, work it out and change and keep going. But my teacher partner, Dijon, she was like, what a whip, my kids arm wrestle, they're good, you the teacher. So if you came to my class, it was just more gentle. Maybe not as much fun, I don't know.
Easy when you
20, but there's, I mean, it will matter, but it doesn't, you know, it's not so.
I'm gonna wait till we get start.
Just one.
12 I rounded off.
Okay, but if I do right here, and then she goes to, oh, okay, then I'm not going to do that.
That's one strategy. If you don't want to do the work, you just stop and let the next person. It's a hard spot, I'm going to stop.
There's something I can do if I write one.
Oh, Jeff!
You got
One or two.
Make him work for it. Nice job. Thank you, guys. So if we give kids this activity and we just say, okay, you did it, now put it in your desks and let's go on, I always found that kids got less and less excited about doing it, or they just they lost interest. So, so something that we started to do that is we thought, what can we do with this? Because all the kids played the same counting game, and until we also gave them days where you could choose. Choose your partner, and then choose where you want to start, where you want to count by, forward or backward. They often chose things much harder than what we would have chosen, so it's kind of cool to give them a choice. So we would ask two things. The first one, not what pattern do you see, because you know kids don't always know what a pattern is, but what do you notice? So is there anything that you notice? So if you say pattern, then I don't know if what I notice is a pattern, right? But every kid can notice something, and you can hold everybody accountable for noticing. So you notice something right off?
The ones digit is either 0 or 5.
Any thought about why?
Because it's, yeah.
Because it's a multiple of 5, 35.
Ah, because 35 is multiple of 5. Somebody else?
Well, my strategy was that every other line, if I was doing this for speed, what I did is I took and I went every other line. So every other line, if I was doing this for speed, I'd say, okay, what's 70 more than 120? So 190, 260, and then I could go back and do the same, because 70 is an easier number to work with than 35 is.
Anything else?
I saw many of you wanted one of them to win. At one point you realized, hey, now he's going to win. Why? Why did you know ahead who will win?
You can only do one or two. Or left. You guaranteed to have one or two left.
Well, at that time there were, let's say, 5 left or so. But you knew from the beginning who is going to win. I do.
I can't, but there is a way. I haven't figured it out. Don't tell them.
Okay.
People have told me, and I'm like, oh yeah, I get it, and I try and
We play this kind of game, and we have a math field day here regularly, and you can modify the rules of the game. For example, one version for me, you have a bunch of pills. Some of them are just like, whatever, M&Ms, and one is a poison. And you know which is the poison, but you have to take a pill at a time. 1 or 2. And the issue would be, you want to avoid to take the poison. That's the poison game version. So the loser is who takes the last. But the other version is that the last thing is a diamond. And you want to earn the diamond, but you have to dig through the other things. You have to take first the others. Who gets the diamond? And how many rows you draw, it makes who is in better position, who has a winning strategy. It will depend on it. So it can be a really neat thing of really wanting to win. What are the conditions of winning?
Yeah, I've had people tell me, oh yeah, I know after the first move, after the first person's move. And they explain it, and I listen, and I'm like, oh, I get you, and then I go to do it myself, and I'm like, so I can get at about 5 or 6 or 7 maybe, but so that's a really nice connection to kids that get into this and want the challenge. How far up can you figure it out and those kind of things. Anything else you notice? So there's lots up there to notice. What do you notice about the hundreds? 3 1s, 3 2s, ooh, 2 3s, 3 4s, 3 5s, 3 6s. Why is there only 2 3s? Was there a mistake? What's going on there? Do you think we ever get to another group of just 200s if we continue? So you can... Yeah, so you can ask them, is that ever going to repeat again? When do you think? When after that? So they can begin to generalize some things. Anything else you notice? So there's other stuff that kids may notice, and there's lots up there. And then the second thing, so we spent just a few minutes on what do you notice, and do you have any ideas on why that's happening? And then the other thing I asked them is, was there anywhere here that it was harder than other places? So where might kids say, or the two who played it, where did you have to think a little harder? when it was going over the 100, like right here? So what did you guys do? So we throw it out to the kids. So if that was a hard place, how did you figure it out? And what might they say? And we only usually did one hard place. So what might they say? How did you get from 365 to 400? Adding 35, what'd you do? So you did 365 plus 30 plus 5. So there's the associative property, and you can begin to notate it in their thinking. So you thought about 365 plus 35. You can even turn it into an equation. 365 plus 35, you said you did it as 365 plus 30 plus 5. Did I do it wrong? Oh, or they might do it either way, right? Some kids might add the tens first. Some may say, I did this. So what properties come out of there? Associative property, commutative property, place value, getting to a 10, or you're going to know how many kids are comfortable adding a chunk of tens. So you can spend as much or as little time, but I always ask those two questions. What are a couple patterns we saw? Why do we think it's happening? And where was it hard? And what are the different ways you figured it out? If it was hard there, what did you do? Because you'll be surprised. Some kids will go, I counted by 5s, or I counted by, so you learn, which is, it's a fine strategy, but we don't want to leave them there. We want to. So at your tables, you just have a couple of minutes thinking about fractions. Think about this game using fractions. What fraction would you want them to count by? Where would you want them to start? And then play the game out and see what kind of patterns they might find. And before I turn you loose on that, this was also, a lot of people ask, did you send story problems home for homework? And my early answer would have been no, because I valued what the parents brought to the table, but I didn't want the kids to be taught the traditional algorithm. So I was talking to a group of teachers that I was friends with, and Mark Carlstrom says, oh, you're a big chicken, Joan. And I said, okay, Mark, you figure out a way to do it so it doesn't come back with the traditional algorithm, and then I'll think about it. Well, he did. So he did strategy night. So a story would go home, and the child had to solve it in a way that made sense to him or her, and then find somebody else in the family that had to solve it, and then they compared strategies. Do you understand my strategy? Do I understand yours? Can I make sense? Could I use yours? So it was used to bring this kind of thinking home. So the kid always had to solve it first, then find an adult. And then it was not about whose is right, whose is wrong. It just, can we learn from each other's? And parents told us, especially the equal share, I never grew up understanding a fraction. I'm drawing pictures now. So this is also a really nice game to send home. Don't send fractions at first, though. It's scary. Send counting by 10. Send counting by 10 or 25 or something like that. But this is a great child and parent game. That's really fun. So play around with what's a counting game you would do with fractions, and then play with somebody at your table.
So if you start at the corner.
And you have to go forward by what?
By 3/4.
And I think if you don't analyze who has a chance to win, then that strategy is not there. It doesn't matter how long someone is sitting and working on something, passes it to someone else, so who cares? So I don't see that without that strategy discussion, the play of I want to win. But you can teach them to work together and having that goal of I don't want to mess up my team's effort, therefore I really have to concentrate on what am I doing. Therefore the whole class can work instead of just 2 people doing the things and the others are cheating. So I think you can have different versions of the same things depending on What is your goal?
And just general counting with kids, having a journal and just asking them, start at this number, count by this number, and I'm going to count past, 15. Start at 2/3, or start at, I don't like to start with small numbers where the change happens so quickly, but start at 2/8 and count by, 3/8 until you get past 15. So they can do it individually. Just a real quickie and then lunch is here. We had a teacher gave the task to her kids, start at 0 and count by 2/3 until you get to, two things happen, until you get to past 14. Stopped. So what do we find out about that child? Till you get past 14. Or a child's just seeing at 2 whole numbers and not really understanding the size. Another cute thing happened where the teacher said, count by 2/3 until you get to a certain number, and the child kept going. So it's like count by 2/3 until you get to, past 30. So the child is counting like this and way flies past 30, right? So, because it's 2/3, 4/3, 6/3, 8/3, 10/3, it's just got all these, this many thirds, this many. So the teacher walks up, I wasn't there, I would have loved to have been there, and said, when do you think you're going to get to 30? And he said, I don't know! So what she said is, do you think you might be close to 30? Or so we had to go back and think about where are my whole numbers in this, because I don't know how big I am. And he did. He was able to go back. She would have got to him sooner and asked that question. But when she did, he had blown right past 30 because he just was doing a pattern, not thinking about how big he's gotten. So just some things to think about. That are easy and simple, but can bring out some really nice mathematics in the class or at home. So our lunch is here.
Remember, we have a working lunch. Right. You have to work all the time. But I really appreciate what John says. I love the games. And by the way, the first thing what she showed was, I heard it, there was a show in TV for a long time, it's Good Morning Miss Oliver. She was a middle school teacher in a really rough area in New York City. And she has a fantastic show. And she used this kind of things, particularly for middle school kids, because she had, this every number can be an outlier, and all the other numbers have something common to share. She claimed that in her class, that was one of the nasty things. Every middle schooler was very anxious about, they are the outliers, they are the fattest, they are the shortest, they have the biggest feet, they have the shortest feet, they have the blonde hair, they have the whatever. Everybody felt, oh, I am the terrible person, everybody else is okay but me. And then showing this, she had this educational goal to show them that, hey, you might be unique in some way, and there is nothing wrong to be unique, you can be proud of it too. Or everybody has some tough things, and you belong to this group in many sense. So that is, I think, a fantastic thing when we teach math, and we teach meanwhile some other wider educational values, not just, hey, here is a number we are picking on. She told them not to pick on each other. So here is a thing, it's one of the journals from Hungary. I told you I grew up there. It was published already in the 90s when I was not there, but I loved that puzzle and challenge culture there. And you won't be able to read what is there, but that's also, I wanted to make a point, because I love educational points. You know how many English learners are in your class. When you pose a problem, many times the problem is not how to solve the math problem, but what is the question? So that's why I chose not to translate to you, but show the original. So you see there are some words which come all the time. Vag, 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 vag. That happens to be, that happens to be a word called cut. So there are figures. This is a very weird shape. These are easier shapes. The issue was to cut this thing into two congruent pieces. This is cut this thing into 3 congruent pieces. Cut this thing into 4 congruent pieces. Cut this thing into 5 congruent pieces. I do the trivial for you. Can you imagine how could you cut this thing into 5 congruent pieces? Yeah, for example, 5 columns, right? Or 5 rows. You might think, is there any other way of cutting? Maybe, maybe not. But that's exactly the issue for these also. Try at least one way to cut it. How many pieces? 2? So you will remember from the 5, you go backwards. 2, 3,